So we will discuss now connected motion. Connected motion is that motion in which the two bodies are connected with each other. Motion of one body is affected by the motion of second body. The best example is mass pulley problem. So we will discuss in this article pulley problem. Pulley problem. So consider a structure like this, a pulley at this point, string, attach two masses. This is angle alpha, angle beta, mass m1, mass m2. Consider it is moving downward, so definitely it will move in upward direction because they are connected motion. They are in the connected motion. So they both have tension T acting away from this point. Weight of this body is in this direction. Drop a perpendicular. This will have angle alpha. Resolve this weight into two components along alpha, m1g cos alpha, and this is m2g sin alpha. If this body is moving upward, the force of friction is in downward direction, and that is in this direction. What this F1 is equal to? F1 is equal to mu1 R1. What is R1? R1 is the normal reaction, which is equal to m1g cos alpha. So this will be mu1 m1g cos alpha. Similarly, this weight m2g downward, this m2g, this angle is beta, then this is sin beta, and this is m2g cos beta. This is the value of R2, because definitely the force of friction will act in upward direction between the block and its surface, and for that F2 will be equal to mu2 R2, and that will be equal to mu2 m2g cos of beta. This is a very complex structure. We have to simply draw free body diagram. So if we draw free body diagram, then we will solve our problem. So let us draw free body diagram. Free body diagram for first body. Tension T upward, acceleration A upward, m1g sin alpha downward, and force of friction downward. So body is moving upward. T is positive and these two are negative. Apply the formula. Net force is equal to mass into acceleration. So this will be equal to T minus F1 minus m1g sin alpha is equal to m1a, or this F1 is mu1 m1g cos alpha, and so this is equation number 1. Let us have free body diagram for the second body. For the second body, tension upward, weight component downward, component of the weight in the downward direction, acceleration downward, force of friction upward. This is positive. These two are negative because acceleration is in downward direction. So we will get m2g sin beta minus T minus F2, and that F2 is equal to mu2 m2g cos beta, and that is equal to m2a. Okay, simply add these two equations. This t will get with this t. So value of acceleration will be equal to minus mu1 m1g cos alpha minus m1g sin alpha plus m2g sin beta minus mu2 m2g cos beta. And on the right hand side, take a as common, m1 plus m2 cross multiplied, you will get the value of acceleration. And if we divide these two equations, we will get the value of t. We can also substitute the value of a in equation 1 or 2, and we will get the value of a, tension T, mu1 m1 m2 cos alpha minus mu2 m1 m2 cos beta plus m1 m2 sin alpha plus sin beta whole multiplied with the g upon m1 plus m2. So this is the value of acceleration and the tension. Suppose we have frictionless track. Both the tracks are frictionless, and for that F1 will be 0, F2 will be 0, this term 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 will be 0. And we will have a very simple equations, and in that two equations we will have the value. Suppose F1 is 0, F2 is 0, then acceleration will be equal to m1 sin alpha, m2 sin beta minus m1 sin alpha upon m1 plus m2 into g, and tension m1 m2 sin alpha plus sin beta into g upon m1 plus m2. So this is the final relation. Now we can put the values of alpha and beta. For example, I have this problem. Whenever you are solving the numerical, definitely you will get the value of mass. You will get the value of angles. Suppose there is a very simple problem in which there are two masses and the arrangement is like this. You have two masses. Definitely this mass will move in downward direction. This is m1, this is m2. What has happened to the angle alpha? Earlier this was the arrangement. Okay, what has happened? Alpha has become 0. And what has happened to beta? Beta is 90 degree. So put this value. Sin alpha we know 0 and sin 91. What will happen? This term will not be there. So it is m2 upon m1 plus m2 into g. And for the tension, this term is 0, this term is 1. So it is t is equal to m1 m2 into g upon m1 plus m2. So for this, the value will be equal to m2 upon m1 plus m2 into g, and tension equal to m1 m2 upon m1 plus m2 into g. Okay, let us have some more examples. The very simple example is this, that you have both the masses in vertical direction. One of the mass is going in downward direction. If m1 is moving in downward direction, I will keep this positive, this negative. m1 term positive, m2 term negative. If m2 going downward, I will take m2 positive, m1 negative. In this case, what has happened to the angles? In both the terms, alpha is 90 degree and beta is 90 degree. Okay, if alpha is 90 degree, sine 90 is 1. If beta is 90 degree, what is there? Sine 90 degree is 1. So this will not be there. And 1 plus 1 is 2. So we will get the value of acceleration equal to m2 minus m1 upon m1 plus m2 into g, and t is equal to 2 m1 m2 upon m1 plus m2 into g. So this is the value of acceleration. Sometimes we can have a very simple example of this connected motion. Both the masses in vertical direction, and draw the article for it. Then we can start the article from very beginning. This is, let us say, these are two masses, m1, m2. Now let us say this is going in downward direction, this is going in upward direction. Tension T, one string, same tension. Weight downward direction. Okay, we can have a free body diagram for this equation. This is going downward, m1g positive, t negative. So net force will be equal to m1g minus t is equal to m1a. And for this, acceleration is in upward direction, so tension is positive. So we will get the value of acceleration and tension from this equation. Add these two equations, you will get the value of acceleration m1 minus m2 upon m1 plus m2 into g. Divide these or put the value of a in 1 or 2, you will get the value 2 m1 m2 upon m1 plus m2 into g. There are so many numericals on this problem, and earlier we have discussed the problem at different angles, alpha and beta. In one case you can consider alpha 90 degree, beta 30 degree, alpha 0 degree, beta 90 degree, alpha 0 degree, beta 30 degree, alpha 90 degree, beta 30 degree. You can solve so many problems. So in today's lecture, what we have studied horse cart problem, in which we use Newton's third law to find out the acceleration produced by a horse by pushing the earth in backward direction and moving the horse in the forward direction. And after that, we have discussed connected motion. What is the connected motion? The motion of two bodies. One motion, first body's motion is affected by the second body motion. We find out the problem for mass pulley at different angles. We obtain the case with friction or without friction, and for different angles we obtain the value of acceleration and the tension. And also we did one numerical on it. Thank you.